I had to disable the chat because although I repeatedly tell that do not write this information of your attendance in the chat, but there are students who are happy with writing here, so I had disabled the chat. If you need to ask something, unmute yourself and say so. In the last class, I asked you that I have discussed the Primsen's Kruskal with directed graph, although which is not supposed to do. Why and all, and I mentioned that if it occurs, and I have stopped at many phases. So I ask you that try with the graph input and try to implement all these things, and then only you can understand where is the problem with original Prim's and Kruskal algorithm. So can anybody tell me what is the problem? What is the problem? These are used, generally these are used for spanning tree. But for all kinds of graph, we are not allowed to use Prim's or Kruskal. Can anybody tell me the reason? Has anybody tried to code? Anybody tried to code the graph-based thing? Anyway, just a very important point that I didn't have mentioned last day intentionally. I'm just showing that if you are taking the short, the thing, this is, or, and this will make you the cycle. Okay. Now, this, and if it is this is not making cycle. But in the original Prim's or Kruskal, there is no method or steps to detect cycle. In the original Prim's or Kruskal, they will stop if cycle happens. Now, how they will identify that? That is a complete different procedure. Yes, I was discussing with a directed graph when I was discussing the Kruskal, and I am telling if it is making cycle and all. But I had stopped multiple times. I was thinking that obviously will point out that Prim's and Kruskal do not have any method to detect cycle, and that is why they cannot be used. Those algorithms are for undirected graph only. So as of now, whatever the graph based we have seen, say BFS, DFS, we have used for the unweighted graph. Prim's Kruskal, that is for undirected graph. Okay. It's finding the spanning tree, which means all the vertices will be there, not necessarily all the edges, not necessarily all the edges. And it's a tree, so it's not supposed to contain any cycle. Now, if you use any other method that whether in a graph there is a cycle or not, and then you even apply the Prim's and Kruskal, still you cannot manage, because if a graph is having cycle, that does not mean that you cannot apply the Prim's and Kruskal. But if the graph is directed one, the Prim's and Kruskal method do not have that much ability to identify. So in the last class, when I was discussing all these things, as I'm a human being, I have at least minimum level of intelligence that I can see with where the direction is. But in case of Prim's and Kruskal, we are not taking any kind of vector or anything else which indicate that in which direction it will go. Okay. So it can detect cycle if it is 1 to 2, 2 to 3, 3 to 4, again 4 to 1, yes, it can. How? Now, whether a node is already visited or not, this way it can try to identify the cycle. But if it is directed, then 1 to 2 and 2 to 1, that meaning is not same. So as a human, with this, you can try to find the a spanning tree. But for a program, and if you are solely use the Prim's or Kruskal original algorithm, then you are not supposed to do. So fine. So whatever the method is discussed, obviously correct, no mistake is there. That for Prims you need to do each of the ages and you need to take in a shorted order all the ages and all. And for Prims, every time you are going for all the fringe nodes, means every time the minimum the value node that you are finding for the next iteration you are taking, everything is correct. As a human being you can do even this one, but as a programmer, if you are using this, you are not allowed to do this because the original algorithm do not have such facility. I was expecting that last day at least one person will point and tell me that this cannot be done or this should not be done, but no one was interested, maybe, or no, maybe forgotten anyway. So today we'll discuss about shortest path. Fine. One algorithm I'll discuss, one procedure we'll discuss with the Dijkstra method. How we are using this. This is for what? This is single source shortest path. Single source shortest path. Oh, sorry. Before this, I had to discuss one thing, that if that way cycle detection is not there, is there any other way? That is disjoint set concept. What does it mean by the disjoint set? Disjoint set means, say, set 1 is having 1, 2, 3, 4. Set 2 is having 5, 6, 7, 8. So is there any common number? No. So the sets are disjoint. There is, if you do intersection of S1 and S2, it will give you the null. So it will be, or you may consider that these two sets are disjoint. Okay. Now, with this concept, the set concept, disjoint set, and with two other operations, say, which are called as find and union. For find and union, using this, we can identify whether a graph is containing any kind of cycle or not. Say there is a graph. Okay. So initially what we can do, initially how this things is done. Find. Find means what? Find operation will check whether it's in some set or not. Now, what are the set you can take? You can take each edge as a different set. Set 1, set 2, set 3, set 4. Sorry, this is 2, 4. And set 4 is 3, 4. I'm taking each of the edges. Say. Or even if you want, you may start with a universal set of all the vertices. That is also okay. 1, 2, 3, 4. That is okay. Fine. So now, find means whenever I am searching for a node and its associated edge. So if I check 1 and 2 or 1, 2, any single one, fine. They belongs to one single set, that is okay. This is also, these are your initial set. These are your initial set. So whenever you want to search for any specific node or any specific line, you can go here and you can get this. Okay. So how these are being formed? That these are being formed from this union set, this one. Now, when you are making these sets, you can take 1 and 2 at the beginning. Next, whenever you need, whenever you next you have 3 and 4, so you can make this one also. How this can be done is it possible that we will be getting without any problem these S2 and S3? Actually no. So whenever you will go for finding 1 where it is available now here, 3 where it is available now in this set. So that means whenever your find operation find two different nodes into different set, then forget about this initially, forget about this. These are being formed from here. So if you are checking that new set, say S3 or S2, you may need to do S1 union S4. Why? Because 1 belongs to this set and 3 belongs to this set. So this will be what? This will be obviously all the elements 1, 2, 3, 4. So what are the thing we have done? We have done it for line 1 to 2. We have taken this for 3 to 4. Then when I am searching for finding or searching for 1 to 3, I have to do this union find. Next line, next is that you didn't have checked, that is 2 to 4. Okay. Now, while you trying to find for 2 to 4, if you find that 2 and 4 belongs to same set, that means it contains one cycle. If you find, see, if you take directly this thing, you may, but the point is how you are finding. You cannot, if your vertices are from the universal set, from there you can take one time the 1 and 2 and another time is 3 and 4. You know that these are the lines 1 to 2, 1 to 3, 2 to 4, 3 to 4. These are the lines. Okay. So when you are taking, you can take 1, 2 at time, another time is 3 to 4. Fine. Next time, if you go for 1 to 3 or 2 to 4, any other line. So both the number belong to two different sets. Okay. So you have to union to make the new set. Once you got the new set, again, if you search for the another line which till now not taken, that is 2 to 4. So if you find both the nodes or both that elements in a same set, you can say it contains the cycle. Fine. So this find and union based method is very popular to detect whether a graph is containing cycle or not. So this is the concept of disjoint sets and the find union. What does it mean? And if two sets are completely disjoint, or means again, even for 2 and 4, if you can get 2 in one set and 4 in another set, you can perform one union. But if they both belong to both other sets, then you can say there is no cycle. Means if this is like this, 1, 2, 3, 4, 5, 6. This kind of things are there. So this is one set. This is another set. If I consider the universal vertices 1, 2, 3, 4, 5, 6, and every time you are taking from there first 1, 2, okay. Then 1, 2, 3, okay. Or you can merge it from there. Yes, 1, 2, 2, 3, okay. Then you take 4, 5. Then you take 5, 6. The moment you will go for either 1 4 or 2 5 or 3 6, say you are going for, say, one set is your 1 2 3 and another set is your 4 5 6. This is now. If I say 2 5, so if you need to do 2 5, so definitely you need to perform S1 union S2. You need to perform S1 union S2. So then all the numbers will be there now. See, if I connect 2 5, it will not make any cycle. But the moment, or if I make only if I search for 1 and 4, they belongs to two different set, then also it will not make cycle. But the very next time, means after you form the S3, the very next time, any two nodes, any edge or any connections that you are trying to produce or trying to search, if that exists, or if you want to use that, if you want to connect those, if you search and if you find that nodes present in the same set, you can conclude that that means there is a cycle, or if you select this line, it will make one cycle. Okay, so this is the concept of your disjoint set. And please read the disjoint sets, because whenever you are going to deal with graph based problem, finding the cycle, whether a thing is given to you is having any cycle or not, this find and union operation is very popular for implementing that. So if you have any question, because there are multiple ways to do this, but as all of you know the Python, and using the Python you can do, or you can use the normal C program to do all this find and union operation. That's your choice completely, the programming language, but this is the concept. There are multiple methods for doing this. There is a total tabular method and all these things, but this time this is required for your programming problem solving. So this much is okay. So if you have any query, you may write, otherwise I will start the next.
What type of question can we expect from here?
Say graph, directly it's given to you any graph, okay, or you may be asked that someone has started from one point and he is traveling around, he is supposed to reach some destination. Means if anyhow you get the idea that something is given, means some road, some distance, some anything else, and you are being asked to check whether he is coming back to same position or not. Coming back to same position means what? Coming back to same position means whether there is a cycle or not. If something, if a ground is circle, so then only if you start in one point, you can jogging and you can come back to same position, right?
Yes, ma'am.
So if after reading this, you understand that only the job is to find whether, not cost, nothing else. If you find that the job is whether it's making a cycle or not, if it is can be thought of as a graph, and if it is asking that whether you are want to make a cycle or not, then you can use this concept. Fine. If it is cost based thing, it will be, there is no requirement of cycle. Or even with other algorithms also, if you know that which particular lines are making the cycle, along with, say, in Prim's-Kruskal, or along with anything, if you, or with any algorithm, if you want to check whether it is making cycle or not, you can use this concept. Okay.
Okay, ma'am.
Because for all these graph-based algorithm, no one will ask you that you use BFS, you use DFS, use spanning tree, use shortest path. No one. from the problem statement, you even in the heap shot also, which are with some priority based things, that same priority things are there, it will be make a structure. Or if you go for say Huffman coding, you may thought of in this way, that in case of Huffman, things are going on this way, that every time you need to take 2 minimum and then you are making something. Again, in the next step, again you need to take 2 minimum and then you go forward. Now, if it is based on say some marketing concept, that you need to take this much money and you need to go forward with this, then you may think, and there are some specific coding. So if things, you need to think that whether this problem statement is matching with that kind of things or not. Okay,
Okay, ma'am.
fine. So Dijkstra algorithm, why it is used? It is one shortest path algorithm. Okay, fine. Next point is what? Next is, it is a single source shortest path. Means throughout the procedure or in one total execution, you can consider only one single source. And another very important thing, that it can be used with positive weight only. Single source shortest path algorithm, and is applicable for single weight only. Okay, fine. So let us take one graph. Say we can take in this way. Please remember that whenever you are doing it by program, every time you will get, or you need to take the input of a graph as a matrix only. No other way is there. No other way is there to okay. Say, oh, কি করলাম এটা? Just a minute. Say you need to find the shortest path. From which source you may take, or the problem may be given to you, or maybe you need to do from any source. So say you are taking A as your source. A as your source. Okay. So A is source. What Dijkstra algorithm says? Dijkstra algorithm says that for any 2 point, say 1, 2, 3, 1 to 2 there exists a direct path, and 2 to 3 may exist another path. But initially you will consider that 1 to 2, that may be at certain distance. So what is that distance? Now the cost that is given here. But 1 to 3 no path exists directly. So initially it will be taken as infinity. And say here some weight, say 3 is given. So at the first iteration, at the beginning, you will think that 1 to 3 is infinity. But when you are considering the path from 1 to 2, then in the next iteration, you will consider that, okay, up to 2, the distance is 2, and then up to 3 is this 2 plus this 3, it will give you 5, which is less than the infinity, and you will get that. So throughout the procedure, what we actually maintain initially, whatever the distance is there, these two are connected, that's okay. So what is the distance of A to B and A to C? A to B, the distance is 2, and A to C's distance is 4. These are directly connected. What about the rest? Is there any direct connection to D? No. So put infinity. Is there any direct connection to E? No. Put infinity. F? No question of connection. So infinity. These are all infinity. Fine. The DISCO algorithm is based on one thing, that if you consider two nodes, this is U, say this is U and this is V. So distance of U means from the starting node, what is the distance of this node, plus cost of U comma V to be compared with distance of U comma V. Now, what does it mean? If this distance, that is distance of U means distance of a particular node from the source, that is A, plus the cost, say this 7, if it is less than the distance of UV, means from here to here, if it is initially whatever the distance is there, if this calculation is less, then that will be updated. If this is less, then this will remain. Means from a general or given algorithm, whatever the distance are being considered from source to a particular node, that node will be compared, the distance of that node will be compared with the distance that can be obtained if you follow some other path. If you follow some other path, then that can be also fine. Now, so while doing all these things, Dijkstra algorithm is based on a greedy method. So what does it mean? Greedy says that each phase for a shortest path, means we are trying to find a minimum cost path. So that's the optimization problem, and optimization problems generally can be solved using greedy, using dynamic, and in branch and bound. So greedy and dynamic mainly. So what we do now, whenever we are going for this, we need to think that every time I need to find the minimum. Okay, so you need to find the minimum. So if you consider all these 2, 4, and these are infinity, you may say, ma'am, there are some weights written, but no, directly you are not supposed to take it. You need to use those weights when you are using calculating this cost. Okay. So if you consider all the nodes, which is minimum, this weight is minimum. So you can consider now B as the nodal point. Now from the B, you will continue. For what? From the B, you will continue with the connections which are associated with B. From the B, it's connected to C. So for the C, what is the, for the 1 from the A, the distance is 4. Okay. You need to take, basically, if I say in this way, you need to take minimum of these two. You need to take minimum of these two. So this is 4. And what is the distance of this U? Now that is 2, plus cost of B to C. Now 1. So now if you see, this is 2, 1, 3, and this is direct 3. So this will be updated with the width 3. So now onwards, we will consider that distance of A to C is 3, not 4, because through the B, there is the updated distance is 3. Okay, fine. What about this D? D is with the infinity. And if I consider through B, this is 2 plus 7, 9. So definitely 9 is less than the infinity. So you update this with the 9. Okay. So doing everything with the node B, that is done. Okay. Next. Again, you find the minimum. So when this is done, you are not supposed to take it anymore. So check which is minimum. This is 3, infinity, infinity, 9. So this is minimum. So now you will go for this node. Okay. Take. Okay, it may be. So Bishwarup has written the attendance again, which is not required. But he has also sent some answer. It's okay if he has done the correct or wrong, we will do. Anyway, so this is the point is next minimum is your 3. Okay. Now you need to check that what are the edges which are connected to 3. Okay. What is source? Your source is S. Don't think that continuously the source is shifting away. So from 3, if I check what is the distance, now 3. Again, the cost is 3. So this distance, that is the E, because with the C, the only connection is with the E. So it will be updated with 6. Fine. No other edges are there connected with C. So you can move forward. So now you will have the nodes with the weight that yet to be explored. One is 9 with 6 and another one is infinity. So 6 is minimum. So here you can take this one, E. So with the E, this side the connection is 2. Means this side one connection is to the D and this side one connection to this side. So if I follow this direction, then this will be, this is 6, this is 5, so 6 plus 5, 11, and this is infinity, so it will be updated with 11. Now, what about E to D? So if you go to this node, then this is 6, 6 plus 2, 8, but it is 9. So it is again updated with the 8. Okay. Now you have the remaining node that is 8 and 11 with the D of U, that is 8 and 11, and 8 is minimum. So you can take this as the 8. And now from the 8, you have only one connection. It is 8 plus 1, 9. And this is done. This is the last node that you can think of exploring. Everything is so. If I consider the distance, shortest distance from A to B, that is 2. From A to C, that is 3. From A to D, that is 8. From A to E, that is 6. From A to F, that is 9. No, we are not thinking, or we are not actually doing that, what is the path or anything. Vishwaroop has given me one way that is following. Yes, we have chosen the shortest path, then so A to B, then B to C, then C to E, then E to D, then D to F. No, I'm not asking about the path. The main purpose is, yes, you can do this tracking and you can get this path, but the point is that you need, if you need for your problem statement, if you need this, that A is the source and rest of the node is your destination. So from one source, all other node as a destination, what can be the minimum distance? Then you can apply the Dijkstra algorithm. So with the same graph, with all initial weight, I request you that say take C as your, if you take any other vertices, you may do it later also, that if you take any vertex as your source, and then you may try to do this. That is also. Now, what is the drawback or what we cannot do using the Dijkstra? Can anybody tell me? It is single source. So do not tell that I cannot do it for multiple source or all source. That you can do, the complexity will increase. The Dijkstra algorithm is having the complexity of big O of n square. Fine, because the entire matrix has to be traveled. Matrix is size is n cross n, adjacency matrix. So the time complexity is n square. So can anybody tell me that if I want to use this for all source, whether it will be okay or not? And another one is, do you know what is the drawback of Dijkstra algorithm? What is the drawback of Dijkstra algorithm? I am putting two questions. One is, if I try to find all source shortest path with Dijkstra, what will happen? And is there any drawback of Dijkstra which cannot be used for all short of staff? Or if I use Dijkstra for all source, this will be n into n square, which will be n cube. So for doing all source shortest path using Dijkstra, it will give n cube, which is very high time complexity level. And what is the drawback? That it works only for positive weight properly. If the weights are given in negative, say instead of 3 or 5, it is some of the weights are in minus. You may say, man, weight cannot be minus, but here it is basically a cost. Fine. So the cost can be negative. That is not actually some value, that minus 5 kilometer is not the way the costing measurements are being taken with the direction or something else. Sometimes the notation may include these negative symbols, but if that kind of things include, Dijkstra algorithm may give the proper result or may not give. There is no assurance. Okay. So is there any other algorithm? There is an algorithm called Bellman-Ford that is also single source, but that allow the negative weight. Fine. Although we are not going to that detail, but this is the point. Now, next the thing we will discuss, that is all source shortest path. This means what? If your target is that you need to find, say you have 1, 2, 3, 4, you need to find the shortest path for 1 to 2, 1 to 3, 1 to 4. You need to find the shortest path for 2 to 3, 2 to 1, 2 to 4, this way. For every node, if you want to find the shortest path to other node, you need to use one algorithm for all source shortest path. Which algorithm is used? Floyd-Warshall's. Floyd-Warshall's shortest path algorithm is to be used if we need to find all source shortest path. Okay. What Floyd's algorithm says to us? It says, first of all, there may be some direct connection and direct weight. There may be some situations when the direct weights are not there, so direct connections are not there, but via some node, some path may exist and so some costing. That's okay. With this particular point that via something, we have taken that point very seriously in the Floyd-Warshalls. Say there is a distance 1 to 2, distance is 7. But there is another path, even we have discussed in Dijkstra also, you have got this, that there is another path where the distance is 1 to 3 is 2 and 3 to 2 is again say 3. So this path is less costly or with minimum cost as compared to this. So Floyd algorithm is applied over each of the node and taking at each iteration taking one node as a fixed, that is all the paths will be compared with as a fix of that node, and it will try to find the final result as per that. So for each node you need to apply the same procedure again and again till you are getting your final answer. Okay. So say this is your graph. If no connection exists, you take that as infinity initially, and for diagonals take 0. So adjacency matrix will be A, B, C, D. D. So what I have told that diagonals will be 0. So take that first. A to B, that is 3. A to C, no connection. Oh, sorry. Wait. Take this one as D and this one as C. So A to C, no connection. A to D with 7. B to A, 8. B to C, 2. B to D, no connection. C to B. Sorry, this is C to A, so C to A, 5. C to B, no connection. C to D, 1. D to A, 2. This is infinity. This is infinity. Okay. This is your initial adjacent matrix. Now, what I need to do? I need to find the distance from A to B, C, D. I need to find the distance from B to A, C, D this way. And every time, whenever I am taking the distance, every time I will fix one node. And I will find the distance with other. So every time I will fix one node which will be considered as intermediary. So every time the node I am going to consider as intermediary, I will take information of that node in row wise and column wise manner in an intact format. So the first one, say I'm taking the A as fixed. So what you should take, you just copy column A and row A as it is, and the diagonal as 0. Okay. This is, and this side, this is A, B, C, D. So what are the things you need to find? You need to find this one, this one. You need to find this one, this one, this one, this one. These many you need to find. So these many means you need to find BC. You need to find BD. You need to find CB. You need to find CD. You need to find DB. You need to find DC. And in each of the case, you need to take A as your intermediary. Okay. In each of the case, you need to take in. So, how we will proceed? It's again like this. The original distance of DBC will be compared with what? Distance of B to A plus distance of A to C. Now, what is the distance of and minimum of these two to be taken as your answer for this iteration? Okay. So distance of B to C, that is 2. Distance of B to A, that is 8. Distance of A to C, now that is infinity. So definitely if I add 8 to the infinity, it will become infinity. So which is minimum? Na 2. So write the 2 here. Okay. Next, what about the BD? Then what is the distance of BD? Now that is already infinity. What is the distance of B to A? You have just taken, now that is 8. What is the distance of A to C? Sorry, A to D? A to D is 7. So you take 7. So you will get 15. So take 15 here. Okay. So this way you just, this way you will continue for CB. So for CB, you just calculate the distance, then CD, DB, DC, calculate the distance and tell me the revised matrix. Do it for A first, tell me the matrix, and then I will tell you what next you need to do. Okay, so complete this matrix, that is MA matrix, by calculating all these and tell me that, then I will continue. Do it now.
Can you once explain the MA matrix one?
MA matrix, I have done only 2 steps you need to complete. The target is that at each step you need to calculate distance of 2 nodes via some other nodes. Now, this via some other node has to be fixed for each iteration. So for MA matrix, I am fixing the first node A. You may take any, but I am taking, just to maintain the sequence, I am taking the A. So if I am fixing the A, then you need to copy the entire row of the A and entire column of the A as intact and the diagonal as 0. Now, once you have taken that, you will get these many blank spaces. These many blank spaces. These distances you have to calculate. If the calculated distance is minimum than the distance that you have here, that will be taken. Or the distance already here, that is minimum, then you have to take this. So when you are trying to calculate the distance between B and C, because that is the gap, then how you need to deal with that? Now, distance of BC in the previous matrix to be compared with the distance taken A as the middle node of B and C. So B to A, what is the distance? That is 8. A to C, what is the distance? None, that is infinity. So 8 plus infinity, that will give you infinity. So between 2 and infinity, 2 is minimum. So I am taking 2 here. Now, if you go for B to D, what is the original distance of B to D in the previous matrix? Now it's given as infinity, because there, that means there is no direct connection. So let us see that whether any distance exists via A or not. Any path exists via A or not. So for that, what you need to take? You need to take B to D. So you need to take B to A and A to D. B to A is 8 and A to D is 7. So 8 plus 7, 15. So if I compare that is with the initial distance infinity, 15 is minimum. So take 15. So I'm asking you this way, you first complete it for all other locations, that is CB, CD, DB, DC. Yes, it may remain as infinity if even via something also the path do not exist, then it may remain infinity. Now, once the A matrix is complete, you just tell me the value, then I will show you how we can proceed. But before that, you just calculate and tell me all these values. That is the thing I am asking from your side. Do it. Tell me the distance of CB, CD, means rest 4. Calculate and tell me. I'm just coming for a minute. Calculate this. Once MA is complete, the next step is you may go for MB. So for B, what you will do? You will just copy the B column and B row from the MA matrix and repeat the same thing. That is, calculate rest of the positions by taking all the path via B. So once you complete MA, I'm just coming in 2 minutes. So once you complete MA, I will write that and then you just go for the MB. This way you need to complete it for all the nodes. When it's complete, the final matrix that may be MD, if I follow the sequence A, B, C, D, that is your final answer. So now you need to complete this, but start doing. I hope you are doing this, just do that. Have you completed the MA? Please tell them. Okay, someone is calling me down.
Yes, ma'am.
Tell me the values.
In B, it will be
No.
3088.
Just tell me what is the value for CB.
CB, it will be 8.
Okay. CD.
CD, it will be 8.
Acha. DB.
DB, I think it will be infinity.
Acha. DC.
DC, I have not found out yet.
Okay, just do it. Let me write the matrix properly. Is there anyone who is getting some other answer? Then also they may tell, and then only I will cross verify. But otherwise, I will assume that everyone is getting same answer. If you do not respond, only one person is doing and others are just sitting all along. So if
From
whatever he
DC,
is
one is coming.
in DC,
One is coming.
D1 is coming. So 1 dB infinity, and as for you, these are both. But CD was initially
No,
1.
ma'am. Sorry, ma'am. In case of infinity, it will be 8.
So this
Actually,
one will be 8.
yes, ma'am. Yes, ma'am. Sorry,
Okay.
I have, and that will be 1.
And this is 1, right?
Yes, ma'am.
Fine. Fine. So the point is, now next what we will do? Next we will do now. So what we will do, that is the MB. Okay. So when you are taking the matrix M of B, then you just fix this one. So then just take this one. This is 3 infinity 7. This will be vacant, and the column is this is 8 and 8. Okay. So now fix the B and calculate this and tell me the distance. Same for C, same for D. When you are doing the C, you take, and now do not take this matrix anymore. Take all the references, means when you are calculating the distance and everything, take the reference from this side. Oh, I didn't, sorry, I am supposed to write the B row. Sorry. This things is 0, 3, infinity. Okay. This is line jumbled up. That's why I have rewritten here. So rest of the positions you need to calculate. Just calculate, and this way you complete this problem and tell me that what is the final matrix. second row will be constant. When you are supposed to calculate the matrix for C node, then only the input supposed to be taken from MB matrix, and only the row for C and column for C remain constant. Rest of the things you have to calculate. And you need to refer to the matrix, that is all the data which are present in the MB matrix. Yes, are you getting the answers? Once complete, please tell me. I will write here the final one. Okay. I'm. I will take the new page and I will write the answers for those who are here to follow you. I will write the answers once you can calculate, and then we will verify with the graph whether that is true or not. No, no further calculation, just by observation. Is it complete?
Final answer will be MD, right?
Yes, final answer will be MD. Let me
Yes.
just draw the graph again. Then I will write the final answer. Let me draw the graph again. And interestingly, complexity of this graph is in the order of n square. And that is why if I need to find this also shortest path, this algorithm is one of the famous algorithm. Again, it depends on your problem statement. If you find that you need to use, you need to use. And as you are doing the calculations, you understand that you just need to do some addition and some max mean of the distance. That is all that you need to do. Okay, so once you will tell the final matrix, I will write here. And
Along the row, it is 0, 5, 3, 2.
0, 5,
No, ma'am,
3.
down, ma'am, down.
Okay, okay. Just a minute. 0, 5, 3, 2.
3, 0, 6, 8,
6, 8,
5, 2,
5, 2,
0, 7, 6, 3, 1, 0.
So if anyone else is here who has completed and getting something else, they can point out if some error is here, because I didn't have done the calculation by myself. Also, he is also a student of your batch. So if some mathematical mistake is there, you may point out. Anyway, otherwise, this can be one answer now. And whenever you will start this problem, even last day I was also discussing that to denote the infinity when no connection exists, you may take a very large number, so that whatever comparison you will do, it will go on. Now just for a check, A to A obviously 0, A to B, that is the shortest distance, is 3, A to B, that is 3, that is okay. A to C, I have, yes, A to C is no direct path, but with updation means with this 3 plus 2. So yes, 5, that is okay. A to D, it was 7. There was a direct distance 7, but it is calculated as 6. So how we can get it as 6? 3, 2, 1. This 3, this 2, this 1, 6. So this is, see, otherwise what I can say, yes, 7 is the distance, but you are getting the path. Thus via this way you are getting the 6. Okay. So this row means from this source, what is the distance of all the remaining nodes? Shortest distance. Floyd-Warshall ensures us what is the next distance. Now, if that I had mentioned also that from a, say for one node only outgoing nodes are there, no nodes are incoming to that, then that node will become not reachable. If not reachable, things will be infinite. Okay. So those who are doing, please, if you are not doing when we are discussing all these things, I'll request you, please do all those, so that while you need to code, you can understand the statement properly and you can apply. Okay. So next we'll discuss about another interesting algorithm, knapsack. So what it is this? 1201900911127 in the bracket MA part another time. Okay. So again I am taking MA was the first matrix. Anyway, in the first matrix, before you start, you need to take the original matrix, which is A, B, C, D, A, B, C, D. The original matrix is 0, 3, 7. For B, it is 8, 0, 2, infinity. For C, it is 5, infinity, 0, 1. For it is 2, infinity, infinity, 0. Okay. Now, this is my original matrix. Huh? This is original matrix. What we do in the Floyd-Warshall, every time we fix one node and we try to find all other node distance via that node. That is our mode of operation if we are using Floyd-Warshall algorithm. So if I'm fixing A for this iteration, then what I'm supposed to do? I'm supposed to copy the complete row of A and complete column of A. Okay. And these diagonals has to be 0 because there is no self loop, no question of self loop rather. Even there exists any self loop, you just delete that. Just delete that. Okay. Now, so you need to calculate this. All these locations you have to calculate. Now, whenever you are calling BC, so what you need to do, you need to calculate it, the distance for B to C. But what Floyd-Warshall says, as you have fixed the A, as of now, you have fixed the A, so you need to calculate, you need to take the actual distance of BC that is given in the initial matrix. Then you need to take BA plus AC, means via A, what is the distance? BA. BA is 8, but AC is infinity. And original B to C distance is 2. So 2 is minimum as compared to 8 plus infinity. So you are taking the 2. If you are going for B to D, then what is the distance of B to D? 7. What is 7? And 7 will be compared to what?
8.
B to A plus A to D. This is infinity and this is 8 plus 7. So 8 plus 7, that will be 15. Now come for C to B. So C to B, what is the distance? C to B, this is given as infinity. Fine. C to A is 5. And A to B is 3. So 5 plus 3, that is obviously less than the infinity. So take this one as 8. Okay. Come for C to D. Okay. So you just calculated C to A is 5. It is 1. So I am not doing further calculation. I know that this is greater than 1. That is via A path. So it will be 1 only. Then if you go for this D to B, D to B is here infinity. So D to A is 2 and A to B is 3, right? So this is why this will be 5. I don't know how this is coming, but this is 5. Just check who has told me that this will be 8. Just check.
That
And
will be 8, right? Or 5.
8. Are you calculating? How you are calculating? Am I doing something wrong? I need to calculate D2B. Yes, I am calculating here D2B, which is here infinity. So I need to take it as D2A. D2A is 2, and then A to B. A to B is 3. So 2 plus 3, 5. As compared to infinity, this becomes
Yeah,
5.
yeah, ma'am. I did wrong. I did wrong.
Exactly.
It
Yeah,
will be
this
8.
happened. When we do manually this problem, this happened. And similarly, if I want to calculate the D2C, so I think this is wrong. So at least 5, not 8. So if I go for D2C, then D2A is 2, A to C, again infinity, right? If I want to calculate D2C, which is here infinity, I need to take 2, and that is D2A, and A to C is infinity. So again infinity comma infinity, this will be M of A. So this is your M of A matrix. Now from here you need to go forward for M of B matrix. So for that, what you will do, if you are doing for M of B, then you just copy column of B and row of B from this one. And what are the positions you need to calculate? Not the diagonals, that must be as 0. You need to calculate for this position, this, 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 sorry, not the diagonal, sorry, not the diagonal, this and this. All the purple positions you need to calculate it for B. Once that is done, take it input for C matrix, and then you take column C and row C as constant and the diagonals as 0, then calculate. This way you are supposed to reach up to this matrix. Okay. So is it clear who has pointed out that facing some problem with?
Yes, ma'am.
Okay, fine. Now we'll discuss about one interesting problem that is called knapsack. So what is the concept of knapsack? Knapsack comes in this way that you have one bag and you have some materials. Some are very costly, some are less costly. You have to take the elements in such a way that your bag will become full. Your bag will become full, and if you sell them, or if you are a thief and you are just storing all the elements, ultimately you will sell all the things in somewhere, then that will be your what I can say, that would be your most beneficial thing. That will be your most beneficial thing. Okay. That is the thing we discuss in the knapsack. Now, knapsack come in two different format. Knapsack problem comes in two different format. One format where you need to do say all the thing of say all the elements which are in a format say intact. Every time you need to take as an intact thing. Okay. And there are times when you will find the situation that the elements cannot be divided. Elements cannot be divided. So if that happen, then you can call that as a means 0, 1 means either you can take the element or you cannot. And if you go for another way, if the elements you have the provisions that you can take only selected part of the element, then you may consider that is a fractional knapsack problem. Okay. So we will discuss that. Say that.
Your screen is not visible.
Yes, I didn't have shared it. I'm sharing now.
Okay, ma'am.
Yeah. So say there is a carry bag which can carry maximum of 50 kg. And you are some farmer, you have cultivated many vegetables and you want to go to market and sell them. So definitely as a farmer or as a seller, what is your target? Now you have to sell a lot of things. You have to sell a lot of things, and as well as you need to earn a lot of profit. Now, if I think about this situation, so before you move forward, you can take that you have produced this much of kgs, and as per the market value, this is your profit. Means if you can sell 10 kg, your profit will be 150. If you sell 5 kg of capsicum, your profit may be 130. If you sell 30 kg of parvel, profit will be 400. And this way you can see all the vegetables. Some of the pictures I have taken, and this is the profit. But if you now calculate what is the total weight, 10 kg of brinjal plus 5 kg capsicum plus 30 kg. Oh my God, this is already 45 kg. Then what I can take? Maybe I can take this 5 kg beans. It's very फायदेमंद thing है कि ये if I sell it, I can get 220. But if I go for this potato, yes, I can profit 500. Now the point is how you can decide. See, this is a sample knapsack problem. It may come in a format that you are a thief and you need to take all the things from a household which are most costly. Or you are a seller, you need to decide what are the things you can, but where is the restrictions or limitation? Now that is the sack size. That is the sack size, the bag size that can accommodate only 50 kg. So, and if you if I randomly take some elements which comprises of 50 kg, that may not give you the profit. Then you think, okay, let me short them as per the profit. But if I try to short them directly as per the profit, what will happen? Now I need to take then 100 kg potato where my capacity is for 50 kg only. So that cannot be done. So what is the method? See, all these elements, the brinjal or the potato, parvel, whatever, it can be taken. Not necessarily you have to take the 10 kg as it is. You can take 1 brinjal, you can take 2 capsicum, you can take 5 parvel and so on. So the point is, you have to decide at which amount which to be taken so that you can profit maximum. How I can decide that? Now, if I can normalize the entire thing. That object basis, per object basis, what is your profit? If you can identify that, and then based on that ratio, if you take the elements, then you will be in a most profitable situation. Again, for no reason, Raima Ghosh. Can you unmute yourself, Raima? CST roll number, CSTA roll number 39. Raima, can you unmute yourself?
Yes, ma'am.
Who asked you to write the attendance in the chat?
Ma'am, no
You have
one.
just joined. You have just joined, and that's why
No,
you
no,
feel
ma'am.
that.
Ma'am, I was there from the beginning only.
But
Ma'am, I
who
just
asked
thought
you to
that
write? Who asked you to write the attendance? Don't write
Okay.
anything other than the question in the attendance. Anyway,
Okay, okay. Sure, ma'am. Sure. Sure.
this is the thing every day I am repeating. Anyway, so
Okay.
if you can total to 15 kg elements, your profit may be this, but you don't have that bag. You have a bag of 50 kg only. So what you can do, now you find that ratio. You find the per kg profit, and then you find that which can give you maximum profit. And according to that, you decide that what amount you can allow. So if you look at this, this is your profit per weight ratio, and you can see the elements which is the highest. Now 44 is highest, which is for beans. Okay, how much weight is there? Now 5 kg. So at present your total sack is empty. So what you can take? Yes, you can take 5 kg of beans. Take it, fine. What is the remaining weight? Now 45. What is the next highest element? Profit per ratio, profit weight ratio? Now 26. Okay, that is for capsicum. How much is there? Means weight? Now 5 kg. I have still 45 kg space, so I can take this capsicum also. Take 5 kg capsicum. Then which is, then 18, go for this. Then 10, then 15, go for. So this way, every moment you will continue. Every moment you will continue. Just a minute. So this way, as long as the space is available, things will be taken. Be it now, you may reach some situation where the total weight may not be taken. So whatever the remaining, say this way, if you continue, this may happen that when you are taking beans, 45 kg remaining, then you are taking capsicum, this much remaining. You can take tomato, this remaining, brinjal remaining, parwal, this is done. This is okay, but it may happen at some situation. See, in case of parwal, you are not able to take the entire 30 kg. You have produced 30 kg of parwal, that is potol, but you cannot able to take 30 kg potol. You can take only 20 kg. That means you have taken 2 by 3, 2/3 of your productions. Okay. So if you taken in that way, that's okay. Sack is full. And after that, you know what is the profit of each of them, if you take 1 unit means original profit, so just take it and you will get the total profit. This is the problem. This is a very simple thing. This is the problem of your knapsack. This approach of knapsack, where at each stage you are, first of all, your target is to maximize your profit. That means it's an optimization problem. So it has to be solved either using greedy or with the dynamic or the branch and bound. That's it. Now, again, more focus. What kind of thing is there? If the elements, see, if now you need to buy some fridge, almari or something, washing machine, there is no way to take 2/3 of the washing machine. No way. Half washing machine you cannot take. You have to take as a whole. So that is not a fractional knapsack problem. This is fractional knapsack problem, and that can be solved in this way. So any problem which comes with this kind of approach supposed to be solved in this way only. Okay. So next we will discuss about some other greedy, or anyway, we'll discuss 0-1 knapsack and then we'll come back to some other greedy method also. Now, if we go in this way, that we will solve and we are getting the fractional knapsack the way we have done, that is okay. But sometime we will get some solution or some situation where you won't be able to go back for your this kind of fractional situation. Then you need to think, but the sack is, that means all other questions, means all other circumstances are same. All other circumstances are same. So if it is goes in that way, then that becomes 0-1 knapsack. You have some element, you cannot take some fractional amount out of that, then you need to take it as a whole total element, then that becomes 0-1 knapsack. Now, 0-1 knapsack is not at all a greedy problem. 0-1 knapsack, the way things, the algorithm is being designed, that is a dynamic approach. What is the specialty of dynamic approach? Dynamic approach means you have to go for all possible situations. You have to go for all possibilities. And at the end, you will decide who is the best. I mean, it's like this, that say there is one competitions, say beauty contests, fine. If see, a beauty contest via, you may say, the reality contest. So in case of reality shows, what happened? At each week we find that some of them are being removed as they are not the best. So at reality show, whoever are the best of the lot, they are being promoted to the next level. That is your greedy. But in case of beauty contents, I don't know much, but I have heard or read in somewhere that it's like that there are multiple rounds, or think about those competitions where multiple rounds are there and everyone has to participate in every round. Everyone, if 5 participant is there, 5 participant has to participate in all the levels, and at the end the total value will be calculated. Now based on the problem, whether it has to be maximized or minimized, the best one will be chosen. Say in the knapsack, if I'm thinking about the profit, all the time we all want profit has to be maximized. Okay. So that is the dynamic problem. Now, so this procedure demands what? The dynamic procedure, what it demands. Now it has to maintain all the result of the previous steps. Otherwise, how it can conclude at the end? No, that's not possible. Directly, nothing is possible. And dynamic approach is one of the a very good or efficient way. We cannot think about the backtracking, because backtracking is such a method which involves a lot of time. Fine. So if I do this dynamic method, one thing that is storing the previous values or previous steps, it's called memoization. Memoization. Okay, it keeps the result of the previous steps. I mean, it's like the way whenever we call the recursive function, that each step it calls for the next one and it come back to the previous one, then we are getting, that is a recursive process. But if I go for the dynamic approach, that is not look like recursion, but it has to keep the previous result in some other method which is called memoization. Now for doing the memoization, we go in a tabular format. Now, so before we go into a direct problem, let me tell one thing. Now the thing is what? There are some elements, there is a fixed size bag, there is some profit for each element, and you have to decide. Now, if you go for random approach, which is called brute force approach. Brute force is also another approach, but that is basically trial and error. Trial and error. You are trying this, okay, that's okay. You are trying that, okay, that means it looks like no, I should not waste the time to use all this example. So now we will take, these are all terms already written here. Say this is your problem statement. Say this is your problem statement. There are items I0, I1, I2, I3. Weights are 3, 8, 9, 8, and values are like this. Okay. So what I can do? I need to maximize the profit. And here I cannot take that 1/3 of I0 or 1/3 of say I1. No, that is not possible. So 20. Brute force approach means what? You may try to check how you can achieve 20. So you can achieve, say if you add 9 plus 8, 17 plus 3, that is 20. Or you can take 9 plus 8, means I2, I3, and then I0, that is 20. But you cannot say that which one is best. Now you can say if you go for the profit value, that is the value that is written here. But this is for very small example, only 4 elements. But if it is more, then how we can proceed? Now for that we have one entire procedure like this. Now before I go into this formula, let me take some values and let me show you how the things are going on. Let me show you that. Say, we will go back to that example also. Say, just take some elements whose weights are 2, 3, 4, 5, and profit of those elements, say 1, 2, 5, 6. This is your bag size 8, and you can see that number of elements are 4. Okay. Now, how we should proceed. We have understood that my profit, if I take 1, 2, 5, 6 weights, 2, 3, 4, 5. And what I told, now I will make one matrix. I will make
Ma'am, your
one.
screen is not present. Ma'am, your screen is not shared, ma'am.
Oh, okay, sorry. Screen is not sure.
Yes, ma'am.
Fine. So this is the enter math. This is the values. These are the values. Weights, say for 4 elements are there. Bag size is 8, and 2, 3, 4, 5, 1, 2, 5, 6 is the profit. P for profit, W for weight. What I need to do? Now I need to go try with all possible weights combination to maximize the profit. Yes, you can see that 6 is the maximum profit, but that doesn't mean that I can take only the 5 and all. So how I can proceed? Now for that, there is, you need to maintain one matrix kind of thing. What is the purpose? Sorry, line 10. What is the purpose of that? Now, purpose is that you will decide that what to take and what not to take at the end. At the end. Now, what is the weight? Na 8. You need to start with a situation when you didn't have selected any weight, and that's why you have no profit. So each column is for increasing weight level. I'm writing this side, this profit and weight, just for proper checking mechanism. The 0th row means you didn't have taken no object, and that's why no profit is there. So no object, so this row will be filled up with 0, and this column will also be filled up with 0. After that, we will go by one inputs. That is, first weight is 2. Fine. If first weight is 2, that means where I can keep it, these are the size. These are the size. Say if bag size is 0, then no profit. Bag size is 1, bag size is 2, capacity is 3, capacity 4, capacity 5, 6, 7, 8. So if I say that I need to take the first element, that is size is 2, then where I should keep it? Should I keep it here? No, because this is not able to accommodate this. As this is not able to accommodate this will be 0. So where I can accommodate this? Yes, this particular position where the capacity is 2, means at least 2, I can accommodate this one, this particular element, I can accommodate here. Okay. Now, what I am supposed to enter here is the weight? No. What I am supposed to enter here, that is the profit. If I select this element of weight 2, object 1 with weight 2, then I should take the profit out of this first object. That is 1. So write here 1. Okay. Fine. Now, for the rest of the things, means even the bag size is 3, bag size is 4, bag size is 5, 6, 7, 8. All these are capable of taking the object of size 2, right? So, and if they are capable of this, all of them can give you profit of 1 unit. Look into 1, sub 1. Okay. Next, come for the next one. Now, next item onwards, what you need to think? First, that element where you can keep it. First, that element where you can keep it, and for next onwards, you have to consider this element along with the previous element. Now, so as the element is of weight 3, where you can keep it? Now you can keep it here. Okay. So when you are keeping it here, what is the profit? Now profit is 2. 2 is the profit for this second object. Okay. What about the previous things? No, they are not capable. So whatever the previous row value, take it here only. Okay. Next, when the size is 4, can you accommodate both the things 3 and 2? No. So you can accommodate only the second object of weight 3, and that's why the profit is 2. Now, 5, 6, 7, 8, for this capacity of bag, what you can accommodate? The 3 and 2, 3 plus 2, to entire 5 kg you can accommodate. Then what will be the profit? Now it will be this. Fine. So for entire rest, it will be. Come to the next object. Again, for 4, you can accommodate it in the bag where this are. And why I'm keeping this? Now 5 is the profit, so give it here. Now, what is the previous? All the previous will be just the copying, because that is not capable of accommodating this. Now, when I'm going move forward, next onwards, what I need to think? I need to think how much I can accommodate in the 5, 6, 7, 8. My third object weight is 4. The capacity is 5. So can I accommodate 2 objects here? 4 plus 2 or 4 plus 3? Unfortunately, that is not true. So I can accommodate only the third object with weight 4. So 5 will be here. For this, I can accommodate this third object along with the first one. So if I can do this, 4 plus 2, so the price, the profit 1 plus 5 will be added. So it will be here. Next, for the 7, I can accommodate this 4 plus 3, these 2. And if I accommodate that, then this will be 5 plus 2, 7. What about the capacity with 8? Is the same thing. 4 plus 3 is the maximum thing that I can accommodate. So the profit will be 7. Similarly, if I go for the last row, you need to think about this fourth object. That is the fourth row. So fourth object, 5, where I can accommodate this. At least here, before that, that is not possible. So, and what is the profit out of this object? Now 6. Do it. Rest. Copy the previous, because they are not incapable. So whatever the in the previous thing, just copy. Next you come here. 6. Again it is 6. So you cannot accommodate any extra with the 5. So take only. So profit will be this only. What about the 7? If you go for the this one, then can you accommodate anything? Yes, 7. So this will be 5 plus 2, and the profit is 6 plus 1. You can accommodate one object of weight 5 and one object of weight 2. And as you are taking this object and this object, this object and this object, so that would be addition of 6 plus 1, 7. And at the end, where the capacity is 8, then you can accommodate this object of weight 5 and this object of weight 3. So 5 plus 3, 8. And what is the profit? 6 plus 2, 8. In this particular method, every time you will get your final result at this, means if your matrix is of n cross n of anything, then at the end position, means this position, the last row, last column, last row, last column, you will get the final profit or the total profit. This is your final result. Okay. But this is not actually this is not actually stopped here. Means this is okay, but you have to know what are the elements you can take. You have to decide that what are the elements you can take. So this is 8. Okay, fine. So 8 is your total final profit. Fine. So if you take this element, total final profit, in which row you are getting it? Now you are getting it in the 4th row. You are getting it in the 4th row. Fine. So for 4th element, how much profit actually you will get? Now that is 6. So what is the remaining amount? Now 2. You need to check where you have got the 2. So if you, obviously you have taken already the 4th element, you are not supposed to take it here. Go to the previous row. That is for the element row for the 3rd element. So if you go here, you can see that this is the row for the 3rd element, and is it corresponding to the profit of 2? No. That means you cannot take this 3rd element. So if I say that 1st, 2nd, 3rd, 4th this way, it's clear that I can take the 4th element, as this is the maximum, and that is I'm getting here, and this 8 also I'm getting here for the first time. No other previous row is with this 8 value, right? So if that happened, then you can consider that this is the first time you, and if you consider the 4th element, then only you will get this profit. So you can include the 4th. 3rd you cannot include because the remaining profit that comes with 8, as the 4th element profit is 6, the remaining is 2. So if you go back and if you check, now this is 0, right? Because this 2 is not actually the profit of the 3rd element. So you go back and you will get, okay, if I go to here, then I can get the profit 2. So you can take this element. Even you go forward, already things are done, that is 0. So if you go for the 0, you can again go back and you will come to the location 0. So this solution ensures us that I need to take 2nd element and the 4th element in the bag so that my profit can be maximum. This matrix is called your memoization. Okay, and see, at each phase you are not deciding which combination can give you base. You have tried with all possible combination, and at the end you are getting the result. Okay, now thinking in this way and finding the result, you have to make your program to think. So what I can do, we can take the help of some formula to do the same. What is the formula? The formula is that is given in the slide. This is the formula that you need to use. This is the formula that you need to use. Okay. K is the row number and W is the column number. W stands for the weight. And look at the matrix. And if you look at the matrix, then you can get the same thing. I'm just showing you one step. This is the thing, elements with their weight, 2, 3, 3, 4, 4, 5 means weight and their value. Maximum weight of the bag is 5, and this is the thing means your this matrix means if you are and your value or the profit is 3, 4, 5, 6. Okay. Now, how you are supposed to do? Now this way 0, 0, 0, 0, 0, 0, all these things. This is the initial thing. Next, what you need to do? You need to fill up all these positions. Fill up. How you will do? My items are this. So take the first element where weight is 2 and profit is 3. So where I can put it? I can put it here. It's 0 definitely, but I can put it here because that is matching. Okay. Now, this is the way I have discussed. Now, if you want to do with the formula, you calculate it in this way. Actually, what it's doing, if you go back to formula, if you want to do complete it with the entire formula, then what you need to do, see, K minus 1, comma W. If WK is greater than, means if W suffix I is greater than this W. W is what? Na column number. That is for weight. Or you need to take what? Max K minus 1. That is, means if you consider the matrix which is comprises of the first row with 0, all 0, say this way, and second you are supposed to do, but the first column position is already 0. You have to calculate this position. If it is, this is say first row, this is 0th row, this is first row, so K minus 1 W. If WK, WI, that is this one, 0, 1, 2, 3, is greater than, means the weight that you are trying to find, that is this column number that you are finding, this is 1, 1, this position is 1, 1. This position is 1, 1. Then it will contain this value if WI is, or WK, I am telling I, sorry, because normal habit of row. If WK is greater than W, what is W? Now W is the weight, the capacity, the weight. If that is greater than, that will be 0. And this way, it will be 0 only. Similarly, if you go forward, K minus 1, comma W means if this is your kth row, then K minus 1 will point to what? K minus 1 will point to the previous row. You go to the previous row and you need to take the element of the same column. Okay. And the element of the element which is present in the diagonal position. Compare them. Whatever is maximum, take that. You need to add the previous value also. So how these are being done? You no need to even remember the formula more elaborately. You can go in this way to look at this. This is the profit. Profit means that is the addition, this added term, that is your profit. This BK means that is the profit. Max of the previous element plus addition of this profit, whatever is max that you need to take. Mainly the elements which are stored in this format, next time it's compared with its previous one and it's being done. Then next time again it is compared with the, every time it is actually compare its previous row element and this side the elements, whichever is maximum, actually that is being taken. Okay. You can use any of the concept, you can use this formula to calculate. Continuously it's calculating. If you want, you can use step by step. If you are not understanding, I am again writing. This is my initial data 2 and 3. So that means I means is basically your K that is in the formula, and WI, so W1 is your 2. This is your W1, this is the element. So first element way is 2, so that is 2. And what is the W? Now W means this one, this is your W. So if WI, that is given there, WI is greater than W, then you need to do what? Then you just need to copy the previous row element of the same column. You need to take the previous row element. Fine. That's why it's coming as 0. In the next step, what you need to do, now you need to take the profit and you need to apply the sentence. So what is the profit? Profit, that is your value, that is 3 plus I minus 1. So that means it is 0. I minus 1 means 0 because I is 1, 0. W minus WI. What is W? 2. 2 minus 2. This is 2 second position. So W will be 2. So 2 minus 2, 0. So 0, 0. So 3 plus 0, 0 location means what? This 0 is there. So 0, 0. So 3 plus 0 is greater than I minus 1 W. Yes, that is also 0. So this becomes 3. Okay. Again for the next step, then W minus WI become 1 because W becomes 3 and WI is 2. How things are being proceeding? The way I was discussing that whenever I am trying to keep the objects here, if I have the first element and that is of weight 2, I can put only the first element in the first row and all the time the profit is 3. So you can understand in this way, but otherwise if you want to do it in some mathematical steps, this is this. Again, things will be compared this way and this will be placed here. This way things will be continued. Okay. Is anything that you want to ask regarding 0, 1 knapsack or fractional knapsack? Because in both the situations, if you identify the problem, then rest of the things has to be done in this way only. Just this way only. You just need to have to identify the problem statement. Plenty of problem comes from this different greedy approach, knapsack. Only the benefit is the knapsack problem can be identified easily as compared to others. That I feel that can be benefits. Anything else that, okay, I'm not getting any question. Okay, fine. It may happen either you know everything or you are just not interested. No issue. Another popular greedy approach is your job sequencing. Again, what is the concept? The concept is that, say, you have to do a lot of jobs, and for each job, you are supposed to earn something. And each job is having some deadline. Means what? Means if you can complete the job within its deadline, then only you can get the profit. If you cannot complete the job within the deadline, then you will not get the profit. Means it's like that you know everything. If you can answer those in the specific timeline in the exam hall, then only you will earn some marks or you can grab some job. Otherwise not. You may be very knowledgeable person, but you cannot apply it within a time. Okay. So job sequencing with deadline, that is another kind of problem. What it do? Now it takes first the number of jobs, their deadline, and their profit. Okay. So most interesting or most desirable thing is that all the jobs it can be done, but sometimes that is not possible. Sometimes that is not possible. Only one job at a time may be done. And if deadlines are nearer, but it's not whichever is giving more profit, we should go for that. This is very common sense, but still one approach is there, so we are discussing. So what do we do again? We short them as per the profit. Non-increasing profit order means we short them as per the profit, and specifically in the descending order, that is maximum profit giving element should be taken first. This way you first arrange all the profit and their deadlines, job profit and deadlines. Okay, so you can see for job 1, deadline is 2 units of time and profit is 100. Similarly for P4, the profit is 27 and deadline is 1 unit. So if you go in this way, now which I should take? That is my entire procedure. So if I take only j equals to 1, only j equals to 1, that is if I take job 1, okay, 2 units. So if I take only 2 units, I will get 100 as my result. But you can see other 3 jobs cannot be accommodated. Okay. Then you have to, you may say, okay, fine, my profit is 100 and done, but what should be my way? I should arrange everything in such a way so that I can get maximum out of it. So if I take only the job 1 and 100 profit, that's actually not good, because in that case, I'm losing the opportunity to offer all other. Then if I take 1 and 4, job 4 and 1, yes, that can be done. You take the one, job 4 first, as it is having 1 unit of deadline, and then you offer it to the job 2. It can maximize, okay, if you follow this sequence. So this way you have to think that which can be taken and which cannot be done, okay. So this is another example. If you want, you may try to solve it. Your job is D1 to D5 with this deadline 22133, and the profit is 20, 15, 10, 5, 1. You may take and you can do a try. So what is this? Now just note it. Your jobs are with deadline 22133, and your profit is 20, 15, 10, 5, 1. Using rules, lots are 0 to 1, 1 to 2, 2 to 3, means 1 unit slot, mainly 1 unit slot. So find the solution and check. Here it's given, just you check whether you have understood it properly or not. Just check whether you can get the optimal solution properly or not, whether you are able to obtain that or not. Just check that. Then we will discuss one approach of traveling salesman problem, but before that, please complete this one. Just this is for your try. You just take 5 minutes of time, and this is a 5-minute problem. Whether you are understanding this or not, So have you got the answer? Have you tried and have you got the answer? I'm waiting for your response, because unless until you try, you also cannot get the idea that whether you are able to do it or not. I'm waiting for your response. I'm waiting for your response. Are you there or I'm alone in the meeting? মেয়ে একাই আছে, তা ভালো। আমারই তো সামনে পরীক্ষা, আমি প্র্যাকটিস করব। হ্যাঁ, আমি তো প্র্যাকটিস করবো, আমারই তো পরীক্ষা। I'm not getting any kind of response from you. Not getting, just not getting any kind of response. Oh, I need to show the question another time. I have just closed the PPT. You just note down the deadlines of 5 jobs are 22133. I'm writing in the chat directly to everyone. Deadlines two comma 1, 3, 3. Profits 20, 15, 10, 5, 1. Okay, you have to find the optimal one. You have to find the optimal sequence of the jobs which can be completed within the deadline and as well as maximize your profit. It will take 5 minutes only, maybe. Once you complete that, please tell me, or I will wait for another 2-3 minutes, then I will start the traveling salesman problem. Wait, I'm sharing the screen and writing there, Nazmin, the screen. Deadlines is 2, 2, 1, 3, 3. Profit 20, 15, 10, 5, 1. So this is the thing. Once that is done, just you can unmute or you can tell. Then we can go for so I'm just telling that if you calculate it properly, most probably you will get 1 to 4, that kind of optimal solution for this one. Just do it and 1 to 4 this way, and the profit you will get, that is 40. That is your optimal sequence will be. Now, if I want to solve traveling salesman problem, the problem solving approach may be any, that may be branch and bound, may be dynamic. Before I start, I should say a line about traveling salesman problem, that TSP is another special and very popular problem, where it says the problem statement that there is a salesman in a day. That person has to visit all the cities. Now, for reaching from one city to another city, you may consider there is some distance, or you may consider some other cost incurs to travel from one city to another. So the person has to find a way so that this cost can be minimized. Now, it may be distance, it may be the travel cost, whatever you may take it as, but the point is that it has to be minimized. That is the main agenda of the traveling salesman problem. Okay. So here 1, 2, 3, 4, you may consider these 4 as 4 different cities. Again, this is comes as a adjacency matrix kind of thing, and you may consider, as you can see, that 1 to 2 is 10, but 2 to 1 is 5. So it's clear that this graph is not undirected. This is basically directed, means going from 1 to 2 take 10, the cost is 10, but going from 2 to 1 is half cost, that is 5. Anyway, that's not our lookout. What we need to find, we need to find that what can be the minimum cost. Okay. What can be the minimum cost? Now, say you are starting from this point, that is 1. You are starting from this point. Okay. Now, how this formula has to be written? this formula has to be rewritten as G of 1, comma. What is S? S means the entire set. What is the entire set? Now, 1, comma, rest of them. So 2, 3, 4. This is what, with this function, we actually try to calculate the cost. With this function, we will try to actually calculate the cost. So next, what it will be? Minimum of CIK. So now just write, I means here we have taken 1. So it is 1K, where the K belongs to S. What is S? Now 2, 3, 4. So this will be C12, C13, C14. This will be your this plus G of, again the recursive approach kind of. So G of K, K is belongs to this. So G of K, S minus K. Means every time which K you are taking, you have to take rest of the things. So how you will continue? So if you elaborate it at least for one step, then it will be 2, 3, 4 equals to, it will be what? It will be C12 plus G of 2, then in the bracket S minus K, means 2 will be not there, 2, 2, 3, 4. Fine, comma, C13 plus G of 3 minus 2, 4, comma, C14 plus G of 4, 2, 3. Okay. This is this 3 value. Out of this 3 value, you need to calculate the minimum. How we can do this? I hope you have looked at the formula. You have noted down the formula at least.
Yes, ma'am.
Okay. So let me take another part. So this way, either you can write it in step by step and calculate each and every, or you may start in this way. Just try to draw in this way. Let's take 1, 2, 3. So this is for 1, 2. This is for 1, 3. This is for 1, 4. Now, then you will get something here, right? So again, so this is for 2, this is for 3, and this is for 4. Now, once you come here for 2, you can again repeat this thing for node 3, node 4. You will do this for node 2, node 4. You will do this for node 2 and node 3. Every time things will be calculated, means this one is that I have written. So if you are coming, so here it was what? Here it was C12 plus G of 2, 3 and 4. It was here. Now, so here it will become what? This is C. This will change here. Here it is for node 2. So 2, 3 means you are now, when you are taking these two, that means you are for this one. So this will be for what? 2, 3, 2, 4. Okay, this is for 2, 3, 2, 4. So here it is for only 2, 3. So you take 2, 3 plus G of 3, 4. G of 3, 4. Fine. Again, you divide it to the G of 3, 4 means cost of 3, 4 plus this one, the similar way, the way we have continued. If as I am taking it from 3 and I'm already taken this, so it will be nothing but the cost of 3, 4. So this way, at every phase, you will get some constant value. The moment you will solve this g of I comma s equals to, with this formula, minimum k belongs to s, then c of ik plus g of k s minus k, this way. So every time s means, in the previous step it was 3, 4. So in the next step, what will be there? Now in the next step, I, that is your 2, and s is 3, 4. So when you are coming here, for 2 to 3, one will be, another will be 2 to 4. So 2 to 3 is this line, 2 to 4 this line. Now in that phase, when you are calculating it for 2 to 3, then it will be g of, again k means your 3, s means what? S means it was 3, 4. So set of 3, 4 minus 3. So it will be only 4. So if I consider now g of 3, 4, g of only 3, 4, consider again this one. So I means now 3 and s means 4. So k belongs to s means k is also 4 only. So this will be what? Ik. This is s, this is k. So ik means cos 3, 4 plus what? Plus g of k, that is 4, s minus s. That means nothing is there. So k minus k 0. So you have almost nothing extra to do here. You will get this way. So continuously for each node you will get, at each phase you will take the minimum, means from these two you will take minimum, from these two you will take minimum, from these two you will take minimum, and at the end you will take the minimum of these three. That is the initial formula. So if you want, you may try this. You can actually, if you want, or anything based on this, you reapply this formula again and again, then you can get the result. So these are the different type of problems from which you, means from these concepts you may get problem. So if you want, you may go through all these. Is it limited to this only? No. Two more type, like your, or the basically the string long subsequence, calculating the subsequence or length of this, that kind of things. I will try to discuss in the next class, because today almost it's 12:25, so I'm not doing this, and I will again ask you that apply the traveling salesman for the given matrix. If you want, I'm giving you the matrix and formula again, and tell me the answer, because you have still 5 minutes and so you can do it. This is the your basic function. You can okay. I expect that I will get some answer. I'm waiting for your response. Everything is that if you know how to solve, doing code for that, is always easy if you know how the things will work. But if you do not know, then trying randomness will result in kind of brute force approach. So I am just giving the data again, expecting that you will solve, and or you take it as a task. Tomorrow tell me that what you can do. So you just take the problem as your task, and tomorrow tell me that what will be the minimum cost by solving yourself, not by opening any other thing on anything. So that's all. You can take your break for lunch or anything.
Ma'am,
And
can we take it as a
yeah, that's
assignment?
what I'm telling, because it will take few time. So you just solve it tomorrow in the class. If you face any difficulty, you tell me. Otherwise, the answer will be around, I think, 35. I had solved it quite long back. It was most probably the answer will be 35. Anyway, you just calculate. If you face any problem, inform me tomorrow. Otherwise, you can break for lunch. Okay. Thank you.
Okay, okay, ma'am. Thank you.